Good afternoon. So now the PT student can mark attendance. Yeah. I think I already shared. Okay, already shared the screen here. It's okay. I think next group, PT20. Yeah. Okay. Yeah. PT20. Okay. One more. Okay. Almost audio. Okay. Done. Okay. Um, so you see anyone join a bit late? Okay, mark attendance now. Yeah. In the first group of all students, not yet in. Yeah. Okay. Okay. So for the previous discussion, any question you want to ask? You made the sections just now. Yeah. Okay. So while waiting for your response, what I do, I run the data the analysis. I think no more. Yeah, the rest no more. Use the software. Okay. 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 So if no problem now, the rest not much. We see a little bit, but basically already discussed. Okay. So we done already. For the potency index. So the map also discussed already. Territorial map. Okay, it's not. It's okay. Okay, no problem. So Okay. Yeah. Okay. This one maybe is a bit better diagram. Okay. So we see the group centroid got 3. Therefore, the over 5 years we got one group centroid. Yeah. So 1 to 5 years and less than 1 year. Okay. So of course there are some misclassification cases. Yeah. Okay. So this is how they work, okay, using the multiple discriminant analysis. Yeah. Okay. So so means basically the pattern is the linear. It's quite linear. The blue color over 5 years is quite high. I mean the function 1 high, the function 2 also high. Okay, is like this. Okay, so it's on the right upper. Yeah. Okay, as compared to other two groups. Okay, like that. Okay, so this is the okay. So okay, see a bit more some concept. Discriminant loading are the preferred method to assess the contribution here of each variable to a discriminant function. Okay, so okay, so therefore the higher meaning the contribution to the function will be more. Yeah, therefore you can also think of this is like the correlation. Okay, so okay. So it's a standardized measure of the importance. Yeah, from 0 to 1. 1 means it's important. 0 is least important. Okay. So it's available for all independent variables, whether used or not in the estimation process. Okay. So unaffected by the multi-cardinality. Yeah, this is the advantage. Okay. So here 0.4. Yeah. So yeah, can be the guideline for us. Yeah. So again, if you want to use it in the capstone, you must do citation. For assignment, no need. Okay. So means more than positive 0.4 or less than negative 0.4. You consider yeah, substantive. Yeah, for the interpretation purpose. Okay. Now we see if there's more than one discriminant function, okay, therefore we can use the rotation loading. It means actually just refer to the structure matrix. Okay, the structure matrix is already rotated. Okay, yeah, the structure matrix is already rotated. Okay, so assess each variable's contribution across all the functions. Can I see use all the functions with the potency index. Okay, therefore this is the purpose. Yeah, why we do the index, the potency index. Okay. So, okay. So the discriminant function must be validated either if a whole out sample or one of the leave out one leave one out position. Okay. This one we can see the idea at least one. Yeah. Okay. So you see actually both also discussed already when we do the multiple linear regression. Okay. How we do this? It's okay. I think I better show you. I think it's okay. No need lah. Okay, no need. Okay, whole sample and also leave one, meaning that you drop one observation. You drop one observation, you test again. Example, you leave one observation, therefore the balance is 99. You do the same testing again. If result different not much, means it's okay. Means not affected by outlier. Okay. Okay. So
So just now in the SPSS, we already take this leave one out. So that means the SPSS already did this kind of validation.
yes, correct. Okay.
Okay.
So yeah, continue. Yeah. So we see also the whole out sample. Yeah. Whole out sample actually is like this. Yeah. Okay. So you can do like this. Let's say 100. Okay. A is 100. Therefore, what you do, you test the 80. You test 80 for you. I think the term that it's okay. That's time series. It's okay. This whole out sample in this module. Okay. So therefore, you use 80 n equals to 80. to do the testing. Altogether 100, but use 80. Okay, and then you do the classification based on the balance 20. Can you see this sample we call it whole out sample. Okay, you didn't use it, you did not use it in your data analysis. Okay, but later you can use this to see either the prediction correct or not. Okay, actually there's one more method. This is the same thing. Okay, the same thing. There's one more method also discussed already. We can make it to 2 subsample. Okay, subsample. And then let's say subsample 1 and subsample 2. If the result similar, means it's good. If different a lot, means problem. Yeah. Because if different a lot, means easily affected by the subsample. Okay, therefore, no good. Okay. Okay. So if no question, means it's almost done for this. Okay. See any question? Hot sample is hot sample. It's different. Okay. Where? Okay. Okay. So okay. 80, 20, hot sample. Hot sample 20. Separate is like this. Subsample 1, subsample 2. Okay. Means why you keep this 20? Because you want to test to see either the classification is correct or not. Can see? Let's say here the hit ratio is let's say is 75%. Now you use this one, you do again the hit ratio. Can you get the same percentage or not? Okay, like that. Okay. Okay. Okay, I give you example. Actually, it's quite similar with the time series. We can discuss also, no problem. Yeah. Okay. So your data, your full data until here, full data until 2021. But you keep 1 year data, this one you did not use in the data analysis. And let's say the result is like this. The estimation, the model is like this. Okay. You should see this table before for those who learn time series and forecasting. Okay, something like this. Okay, you may call this a train data. Maybe I'm not sure. Maybe I think so. Yeah. Okay. The term used by data scientists and statistics, some term a bit different. Okay. So you get the model like this. Okay, and then you do prediction using the model. Therefore, you get this. Let's say like this. Therefore, the black color is the forecasted. Okay, forecasted. Okay, I use different color. So, and then the purple color is the actual. Therefore, this one maybe not so good forecasting. Can you see the forecasted is higher, more, compared to the let's say the share price. Therefore, the price is quite higher compared to the actual. The purple color is actual. Okay, so this is maybe trend data. For us, we call this this one we call this in sample forecasting, in sample. Okay, so this one is let's say this is out of sample, forecasting. So means now we are let's say 2022. You can forecast for the tomorrow share price. Okay, therefore it's out of sample. Okay, therefore this is quite similar with the whole out sample. Yeah, not the separate. Separate is like, oh yeah, yeah, separate like this. Yeah, subsample 1, subsample 2. We separate the 2. Okay, a bit different. Okay. Yeah. Yes.
So this whole out sample, you can set in the SPSS or you have to do manually.
No, do manually. Do manually.
Manually, normally it should be done randomly, right, for the sampling.
No, this one we cannot do it using SPSS. Yeah. For forecasting, I think yes, but not the multiple discriminant. Okay. Yeah.
Okay.
Okay. So if no problem, now we see.
Sorry, sir. For cross validations, so is the sample size is the same for both subsample?
No, actually, these two supposed to come together. Okay, now it's the same thing. Yeah. So means step 1, you analyze data, you analyze the sample. Okay, analyze the sample, and then you do you utilize the whole out sample. Yeah, same thing. It's same thing. Yeah.
So cross validation come first before we utilize the whole out sample.
Okay, it's the same thing. Wait, yeah. Okay. Cross validation. Step 1, you analyze the data. Okay. So second, you utilize the whole sample. Can you see? Okay. Suppose like this. Okay. Yeah. So this is the 80. This is 20. The 20 that is in your sample, but you did not use it. You did not use it in stage 1. You use it. This 20, you use it in the second stage. Like that. Okay. Okay. If we are. Okay. If no problem, now we see some. Actually, almost done. Is this section we can discuss? Yes. Hello. Ask now.
So in the step 1, when we analyze the data within the 80 samples, so here already we got the hit ratio because it's tested also against its own data. So if the hit ratio is good, then if we use that, the model or function 1 we use to predict for the step 2. So by right, the hit ratio should be almost similar as the step 1.
Yes, correct. If also almost similar, then okay. If too low means something wrong. Something wrong. Means the result easily affected by the sample. Can you see? Change the sample, result change. If result still quite stable, therefore it's okay. It's good, like that.
Okay.
Okay, yeah. Okay. So if
What is the rule of thumb of the ratio?
okay, if you see the slide minimum 20, actually for me still too low, maybe 50 lah, yeah. But again, you must see in the test or exam you can follow this percentage. It's okay, minimum 25%. But actually for me it's still too low. Okay, so yeah, but it's okay for the test quiz. We just follow 25%. Follow the guideline. Okay, yeah.
Okay,
I mean the hit ratio 25% and above consider good lah. Okay, so okay, we see some checkpoint, a quick one. When should we use? Of course, you must consider your data, right now. Consider the data and then your objective. Data meaning that the dependent must be metric. Sorry, dependent must be non-metric. Okay, and then the independent must be all metric. Okay, and then objective because you want to do classification. Can you see? You need to classify the what they call. You need to make sure that you can classify the correctly. You can classify correctly the respondent into each category. Okay, so based on the independent variable. Okay, and we should use this when you know when the group actually is known. Example, they already purchased the iPhone 14 or like that. Okay, you know already. Okay, example, they already purchased the car. Yeah, the car that introduced by your company, like that. Okay. I mean, let's say this is newly launched. Okay. So, okay, these few things we should consider. Okay. Okay. So for part two, of course, we see also the major consideration. Of course, must be see the assumption. Okay, assumption and also actually quite similar also if number one. Yeah. Okay. Means beside the rest is same. Yeah, means the data also the objective. Yeah. Okay. So these few things. Because you should consider the assumption, means testing to make sure that the data meet the assumption. And then what kind of data you have? Different data, different testing. Yeah, for multiple discriminant with our requirement. Yeah, for the on the data. And also the objective. Okay. Yeah. So which measures are used to assess the validity of the discriminant function? Yeah. This one I think discussed a little bit just now, including the potency, yeah. Okay, potency index, okay, and also the whole out sample, okay, or better use the cross, okay, cross validation, okay, and then also subsample, okay, yeah. So yeah, so these are some example that we can use here to measure the to assess, yeah, okay, to assess the validity of the discriminant function. Okay. How should you identify variables that predict the group memberships? Wow. Okay. How are you going to identify? So of course got few method. Yeah. So first is the univariate ANOVA. Okay. From the output. So second is using the uh, discriminant function. Third is using the potency. Okay, potency indexer. Okay. So therefore, we know which one actually can predict the group membership. Wow, which one not too good, which one is better, like that. Okay. Okay. So that's the learning checkpoint. This is data set that we are using. Yeah, some we have, some we don't have. Yeah. Okay. Yeah. Any question for so far? Yeah. Okay. I give you 10 seconds. Yeah. Okay. So if no, now we see tutorial. Confirm no? Okay, wait. Go. You want to know how to do prediction, yeah, once function 1 is selected. How to predict function? What do you mean by this? Explain a bit more. What prediction you want? You mean the hit ratio or what? Are you saying the hit ratio? No. Use this model to do prediction. Yeah. Okay. So of course we can do prediction. Okay, we see. Okay, now, yeah. Okay. Okay. So a quick one. Yeah. Okay. So 5 until 11. okay, I can show you the d power 2 now. Yeah, I forgot. Okay, so you can see d power 2 now. Okay, yeah. Okay, method. Can you see here? Yeah, this one. Mahala Nobis. Okay, d power 2. Okay, so this is correct, but not too not too easy for us to remember. Can you see? Because this is the critical value. Yeah, but therefore better use this. Your p value. Okay, p value. Okay. Meaning that let's say 0.05, the f 0.05 we should include. Yeah, can you see? It's similar if the one that we discussed previously under the multiple linear regression. Okay. So but more than 0.0, more than 0.1 we should remove. Okay. Classified. Okay. 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 So now, what we can do actually is only the roughly actually, yeah. Okay, it's roughly, not too accurate forecasting, not too accurate prediction, yeah. Okay, I mean to do the prediction because, okay, we see the, yeah, the potency index also, yeah. Okay, so we see the first one, the ranking number 1. Okay, so means we can use this to do the prediction. Okay, complaint. Should we discuss already? Is it? It's okay. It's okay. Okay. The complaint resolution 1. Okay. Therefore, as what we discussed just now, if the point, the rating is high. Okay, the rating is high. Therefore, most probably the person's income is considered high. Can you see? Complaint resolution normally give a low rating 4.5. Yeah, so for the low less than 2,000 ringgit income category. Okay, but more than 4,000 should be higher rating. Yeah, 6.9. I mean, sorry, yeah, 6.35. Yeah, 6.35 like that. Okay, so this is a roughly prediction that we can use. Okay, yeah. Okay. Yeah, so this to answer yeah, your Xiong. Yeah, thank you. Okay. So now we see the, yeah, this one. Yeah. Yes, ask anything?
Yeah, the D square right now.
Yeah, correct. Yeah, thank you. Okay. Okay. So we see okay. Yeah, correct. Can you see? D square. Yeah. So this method is using the Mahalanovis. Yeah. Therefore they use D square. I mean the method is called it Mahalanovich distance. Yeah. But the statistic that they use is D square. Okay, it's a D square. Okay. So okay. So this one is they compare pay by pay. Okay, between these two groups. Yeah. 3,001 to 4,000. Yeah, and then and also more than 4,000. Okay, this is the statistics. Okay. Okay. So we see this one. We should include this. Okay. Wait. Yeah. Okay. Um. Okay. So this is based on the statistics. Yeah. This is the p value is quite high, but perhaps no what do you call no variable is less than 0.05. Therefore, they can include this also. Okay. Okay. So then this is the smallest they include. Otherwise, maybe no cannot find variable in the model. Okay. But here is considered more less than 0.05. Therefore, they include this. Yeah, because it's a model content, only one variable can be different. Yeah, okay, with others. Okay, so among the variables, this is the p-value of this is smallest, therefore they enter. Okay, like that. Okay.
So sir, the D square is a statistic, the value?
Yeah, this square is a statistics. This square is the test statistics. Yeah, 2 by 5 something. All this.
So the higher it will be removed.
Okay, so here actually the higher they should consider. Yeah. Okay, the higher they should consider. Yeah, they should enter. Okay.
Okay, so okay, I just saw this remove on the step number 4.
No, one is enter. This is a remove. Okay. So we see the final. Wait. Wait. Actually, you should see this. My mistake. Yeah, you should see this. Yeah. Okay. Okay. We see step 1. The variable in the model 1 is significant. Yeah. Second also significant means I'm sorry. This is not correct. You should use this is not correct. We should use this. Yeah. So you see the maximum number of steps is 14. Okay. 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 I'm sorry. Okay, you see, so the variable that maximize the distance, yeah, between the two closest group is enter. Okay. So means d power 2. D power 2 is the highest. Okay, between the two closest group is enter. Okay. So maximum number of steps is 14. Maximum significance of p is 0.05. Okay, therefore it's the value that we use means 5 0 until 0.05 we should consider, we should enter. Okay, so remove 0.1 is in the what they call in the setting just now. Okay, so therefore model 1 they enter the complaint resolution because f is the p value for the f is less than 0.01. Okay, so okay, and then model 2 they include 2. Yeah, okay. Okay, so you see here they compare the two groups less than 2,000 and also 2,000 until 3,000. Yeah. Okay. Yeah, I think my mistake. They should actually consider the minimum. Yeah, minimum d square. Okay, not the maximum. Yeah. Okay. So until here they may remove or maybe enter it. So finally we get this model. Okay. So all are significant. Yeah, the f all significant. Yeah. Okay. So you get 3 models. Yeah. I mean three variables. Okay. So it's okay. So but I think a little bit different compared to what I mean the outcome a bit different. Kau nak 5, 9, 10. Otherwise, I think better use our discussion just now. Use this maybe a bit confused. Okay, because here's stepwise. Here's stepwise. Some model they did not consider, therefore outcome a bit different. Okay, it's logic. Yeah. Okay, but for us we focus more on the method just now. Okay, yeah. Okay, so we see tutorial. Wait. Okay. Okay, so we see tutorial now. Okay. Anyone? Okay, it's okay. A quick one. Okay, a quick one. Okay. Yeah. So discriminant. How would you differentiate between the multiple discriminant analysis, regression, and also ANOVA? Okay. So, okay. Okay. So for the multiple discriminant, the first thing we see the dependent, the variable, okay, MDA, multiple linear regression, and also ANOVA. Okay. Analysis variance means ANOVA. Okay. So we see for the multiple discriminant, the dependent must be non-metric. Okay. So independent must be metric. Okay. Multiple linear regression, both dependent, independent, both must be metric. So for ANOVA, it's the same if the MDA. Yeah, dependent, independent. This is a non-metric. This is the metric. Okay. Okay. So this is the first. Okay. Second thing, the objective will be different. Okay, among these three. Yeah. So the objective is cause effect. Okay, cause effect. And then MDA is more to classification. Okay. So ANOVA is the between group effect. Okay. We only want to see the two groups. Do they have any difference? Yes or no? That's it. Yeah, compared to MDA more advanced. Okay. Multiple discriminant. Yeah, the analysis is more advanced. Yeah. Okay. Means under the MDA, not only see the between group, but only see the classification. Therefore, more thing to examine under the MDA. Okay. So yeah. Okay. Any question? Yes. For this part, or any idea? I'm thinking any other different thing.
Well, this MDA doesn't have an equation. MLI has equation.
Okay. Okay. The focus will be different. We are focus the overall model. We want to see the hit ratio. Okay, the overall model hit ratio. So this one is equation. We want equation and also the F test statistics. Here is F lah. Okay, F. Okay, the Fisher test. Okay. Any other comment?
So we are not going to learn the ANOVA, as you say.
ANOVA you learned already in statistics.
Oh, okay.
Yeah, it's the last subtopic.
I
Okay.
was not in the statistics class.
Oh, okay. You are IT. You mean your first degree is IT?
Oh no, I study bachelor degree in other university.
I mean, what program? What program?
Actually, I'm from mechanical engineering.
Oh, okay. Then why you now need to take the statistics? Suppose compulsory.
Oh no, this is my master degree in AI.
Okay. You're not data science. Okay.
Yeah.
Okay, thank you. Okay. So basically, these are three important things. Okay, yeah. So actually, we also discussed already ANOVA, correct or not? Yeah. Actually, a bit, just a bit, not much. Yeah. Because oh yeah. Wait. Okay. Yeah, this is ANOVA. Okay. This value is to test the ANOVA. Okay. Yeah. So continue. Yeah. Number 2. Anyone? How does a two group discriminant analysis differ from a three group discriminant analysis? What is the difference? Okay.
Is this related to the last time you said about the extreme groups and no?
Not necessarily. Yeah, two groups can be extreme, can be non-extreme. Yeah. Okay. Okay. But first difference is that in the two group, the potency value, is already potency index. Okay. Yeah. Can you see? This is the first difference. Okay. Second. Second, two groups. There's another option. You may consider to use logistic. Let's say two groups. Yeah, it's still possible to consider logistic. Then you compare, yeah. And then you have, of course, different interpretation, yeah. Okay. So logistic regression is still possible, okay, but 3 groups cannot. Okay, logistic regression must be 2 groups only, yeah. The dependent variable must be only 2 groups, yeah. 3 groups cannot, okay, yeah. Okay, yes. Try to see any more. No, okay. So I think that's all. We
How
see.
about the ranking also?
No, the ranking, either one you must do. Yeah, the ranking of the potency index. You still need to do it either 2 group or 3 group. But just that, okay. The ranking, you do it based on the potency index. But let's say you got only one group, yeah, okay. If only 2 groups, therefore most probably you have only one function, cannot be more. Therefore only one potency value. Your potency value will be your potency index already. Because one function, you can say one function. Here got 3 functions. You take 2, therefore must do some calculation to get the potency index like that. Okay.
So the question leads me to ask, I mean, for example, use this one, the income group, we have 4 groups.
Yeah.
So I'm not sure whether, if let's say we will test another case with 3 groups, but the income level, like maybe the first group is a different kind of range, but only 3 groups. So should we test that kind of different grouping for this MDA, or?
Let's say your data only contain 3 groups, then 3 groups, you cannot make it 4.
Because it's the data is already collected in this way.
Yeah. Okay.
Okay.
It's okay. I share now. It's better. Otherwise, I forgot. Yeah. Okay. Again, I'm sorry. These 2 days are quite busy. Okay, is the preparation of class and also other things. Therefore, I not get check not get reply the file, your email, also the Teams. Yeah, but I try to do it tomorrow. Okay. I mean some student asked me to check the data, but not yet. I think tomorrow. Okay. Okay. Yeah. Why cannot? Okay. 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 So continue. Yeah. Okay. So, okay, if no question, now we see how does discriminant analysis handle the relationship, okay, of the dependent and independent variables. So therefore, one of the example is you can use the mean, okay, the mean value. Okay, so the mean value for different group is different. You can use it as a method to distinguish, okay, the group. Yeah, this means different. Example higher, it's okay. It's different example. Income is good example, but another example, anyone? Okay. Yes. Quantitative, and then also the quantitative, and also the okay, quantitative and also what they call quantitative and also the the non-metric. Okay, so okay, let's say the spending over payment, yeah, may use this. Yeah, let's say okay, spending using credit card, yeah, spend too much but use quite small, yeah, quite little. Imagine, let's say spend 5,000 ringgit per month using credit card, but payment is only 1,000. Therefore, this value is quite high, yeah. This value high is quantitative. Therefore, high chance here will be category as non-performing loan. Okay, this is another one is a good lah. Okay, this is a normal case. Yeah, normal case. Okay, so this one can be also one example. Okay, that we can use. Okay. Okay, so let's say this value higher, the mean higher, therefore most likely will fall into this category. Okay, this is the one example. Okay. Okay. So if no problem, now we see. Okay. So requirement to perform the discriminant analysis, yeah, in terms of the number of dependent. So of course must be only one. Independent, actually must be two because we are doing multiple, right? Multiple discriminant analysis. Okay. Okay. Yeah. Therefore done already, right? The measurement slide. Therefore this one must be non-metric. This is simple. Okay, simple. This one must be metric. Okay. So the independent must be metric variable. Okay. Okay. Now you are engaged as a consultant to conduct a research using discriminant analysis. Illustrate qualitatively the use of DA by referring to one example in your answer to the following questions. Your example should contain at least 5 hypothetical independent variables. The dependent and the independent variables chosen must be conceptually valid. Yeah, means at least you can discuss it, the impact on the independent logically. Okay, means why the independent variable is quite helpful. You have to distinguish the category. Okay, yeah. Okay. I think I try to give you example. Miss here can give any example, but must be logic. Yeah, must be logic. Okay. Yes. Okay, 5 variables, and then the grouping can be less, but the variable should be more. 5 independent variables. Or anybody can try also. Then we can develop the example together. Yes. The objective and then dependent, independent. Yeah. Okay, we may consider to use the no, finance cannot. Banking already discussed. We try to use different example. Yeah. Yes, anyone? No. Yes. Because the independent must be metric. Okay. The independent must be metric. Okay. Okay. So you may see this example. I'm thinking this. You may consider. It may help to find the independent variables. Okay. So this is based on the latest trend. You cannot. I think iPhone 14 just launched. Okay. So buy or not to buy. Okay. Buy or not to buy. Okay. So therefore, this is the okay. Of course, cannot be. This one must be non-metric. You cannot say buy half. Okay, no such thing. Yeah. Of course, if buy can be installment. Maybe some shop have. I don't know, but cannot be quantitative. Therefore, must be qualitative. Okay. Buy or not to buy. Okay. Therefore, we can actually briefly explain your. Okay. So here. You can survey, maybe not buy, but would buy. Okay, would buy, okay, and would not buy. Okay, yeah. So means we know also the category, okay, the category of the observation, the respondent, okay. So therefore this is the research purpose to see which category of people they will buy. Okay, they will buy the iPhone 14. Okay, the new iPhone 14. Okay, so this one should be okay. You have to find the research objective. Okay. Okay, means you want to predict. What kind of. You want to predict who will be the who will purchase, who will fall into which category, either would buy or would not buy. Okay, so like that. Okay, so the dependent already done. The independent can be, well, yeah, as usual. So income second, yeah, maybe age, yeah, maybe age. Okay, any more? It must be quantitative. Okay, must be quantitative. Yes.
Like the number of years of their current phone, if it's already
Okay,
like,
okay, good.
then yeah.
Okay, so current handphone usage. They say already used many years, therefore high chance to purchase.
Yep.
So most probably they will fall into the would buy category. Okay, so yes, two more. Again, that must be quantitative. Yeah. Okay. Yes.
I say also maybe the number of I mean the length of time they spend on social media, because I mean the advertisement of iPhone 14 is coming out, YouTube or Facebook.
Oh, you mean they see the advertisement more, they will buy.
I mean the number of time spent on social media, the advertisement may come out or may not, but maybe the more
Okay.
time you spend, then the chances you see may be there.
Okay. Okay, because you access to the social media, then you can always see the advertisement of the i14. Okay.
Well, the chances are there you will see more if you spend.
Okay. Good. Yeah, good question. Good question. So, uh, anyone? Uh, okay. Okay, the time spent, yeah, the time spent on social media. Okay. Yeah, so logic. So this is logic. Okay, yeah. One more. So spend more, therefore they will see the advertisement are more frequent. Yeah, therefore they may influence by the advertisement finally purchase. Okay, logic. Yeah. Okay. Okay. Yeah. One more.
Product specification.
Okay. Actually cannot use this because okay. Well, maybe there's a time that you should know what is the difference, okay, between the structured data and non-structured data. Okay, so the any topic that we learn in this module, there must be structured data. Okay, structured yeah, data. Okay, so but of course for you, you should also good in the non-structured data. Okay. Uh, okay. So what is the difference between these two? Okay. So for any data set that you want to apply in this module, actually must be structured. Example is like this. Means the data that you are using must be able to put it in the data sheet like this. Okay. Example observation 1, therefore got some variables. Observation 2, some variables. So for you, you must know. Now, actually, you must know both. Okay. Therefore, but of course, you will be really good. You should be really good in the non-structural data. Okay. We see. Okay. let's say you want to means you should know this first, okay? Then you only know how to do modeling. If you want to use the method that you learn in this module in your capstone, okay? So must be structured, okay? We see the example that we are using. The dependent is correct purchase or not? We are buy or not to buy? Okay, would buy, okay? Would buy or not, okay? And then this is the first variable, okay? And then we say income, yeah, and then age of the respondent, and then the social media, kan access to the social media, okay? And then
Ease of use.
okay, age of use, okay? So therefore,
I mean, ease of use, easy or not to use the handphone or not compared to other phones. So people will might buy iPhone.
no, also cannot. Okay, I show you now. Yeah, why cannot? Yeah.
If we turn into liquid skill, can we use it?
No, cannot. Because this one you should focus on the people, not the handphone. Can you see? This one means the first respondent may answer yes. Okay, going to buy. Yeah. Income, let's say 5,000. Example. Age, let's say 30. Example. Social media, we still can measure it, but based on the focus on the respondent, not focus on handphone. Let's say this one, they access 3 hours in the what they call it, the social media. So the current handphone already used for let's say 3 years. Based on your whatever what you are going, what you're suggesting, this one. Oh, okay, specification. Okay, specification. How are you going to put the value here? Can you see? Cannot. This value must reflect the variable, the respondent. Means ask the respondent to fill in. Can you see? Okay, you cannot put in this. Yeah, how are you going to, this is for handphone, not for the people. Example, second respondent are not going to buy. Income, let's say 3,000, example. Okay, age 40, yeah. Social media 2 hours. Age or age 2. Okay. But this one, how? Can you see? Okay, before data that you are going to use in this one must be structured. Okay. Okay.
So is it possible like MLR we can put the category info by putting the dummies here? Is it possible for the dummies?
So what are you going to put? This is multiple discriminant. What are you going to put here?
I
Let's say
mean,
hi.
for example, staying in urban and staying in rural. So
Urban can. Urban, rural, semi-urban still can. Yeah. Example, one for urban. One for urban,
yes.
and then two for semi-urban, like this. Okay. So and then three for rural, still okay. Okay. Means one is more in the area which is more developed. Yeah. Three is least developed, like that. Still okay.
So these are considered dummies, right? Is still possible.
This is not dummy.
Not dummies, huh?
Dummy. It's more like a skill, something like that. Yeah.
Or
It's
like
categorical, but
more.
no, ordinal. This is ordinal. Yeah. Okay. But ordinal still flexible. You can consider as the skill, still okay, but not the specification.
If it's or if there's some skill there, okay.
Yeah. Some skill. Therefore here you can use the area. Therefore 1 and 2. Therefore done. We got five independent variables. Okay. Okay. You see non-structured you may learn. Okay. It's okay. Since you are here, can discuss a bit more. Since you are a master, you should know more. Okay. Non-structured data is like what? Like non-structured can be really broad. One example is just now you can include the specification, okay, into the modeling. You can also include, you can also consider the data from the Facebook. Can you see? Then you can predict who will be the which party will win in the general election. Okay, can you see? Yeah, means you can analyze the qualitative data. Okay, of course, for us, it's more to quantitative. Okay, okay, like that. It's unstructured, you can do, but not for this module. Okay, this module, everything must be structured. Maybe except the SEM. Yeah, a bit unstructured, still can use. Okay. Okay, so we continue.
So that means this whole thing is targeted on users rather than on the iPhone, on the handphone itself, right? So if I want to include gender inside, also can, right? By converting it to dummy variables.
But you try what variable you want to use?
Let's say I want to use gender, but I will convert it into a dummy variables like 1 and 0. Can I use it?
Not encouraged because this is not the multiple linear regression. This is the multiple discriminant.
Got it, sir. Thanks.
Okay. Yeah, like that. Okay. Okay. So in multiple linear regression, yes lah, you can put in gender. Yeah, one for male, two for female. No, sorry. Yeah, 1 0 must be 1 0. Okay, let's say one for female, two for male, 0 for male. Okay. Alright. So must be 1 and 0. Okay. So we see question. Oh yeah. Okay. Okay, here is another example. Customer satisfaction, user experience. Okay, user experience can be ordinal, can be used like a scale. Okay, quality and after sales service also like a scale can, but not enough. Only two. Can see you have only two variables, two independent. Okay.
So minimum is 5, is it?
I mean for this
Independent
example,
variables.
it's 5.
I see. Okay,
Okay.
right. Thanks, sir.
I mean for this question. Okay, for this question. Okay, you see a bit more. Yeah. Independent, prospect income, monthly data. Oh, okay, this is the, okay, this is handphone. Can not? Oh, okay, yeah, the handphone. So independent and then prospect income, monthly data, plan expense. Okay, second price of on handphone. Okay, good. Number of phone on age. Okay, yeah, okay, good also. Yeah. So because by logic, if let's say currently the handphone they use is only 1,000, I think maybe not going to buy the i14. Maybe not maybe not. Okay. So logic, yeah. Okay. So yeah, this one also good. Yeah, thank you. Okay. So okay, any question on this number 5? Okay. Okay, so if not, now we see next. Yeah, I think we try to finish this one, then go for tea break, then come back for factor come back for the logistic. Okay, logistic regression. Okay, so 3 assumptions. Any problem to find the assumption from the slide? I also cannot remember. Of course, I can remember the dependent, independent, and the sample size must be more. Okay, this assumption. Yeah. Okay, alternated. Okay, stage 3 assumption. I think the assumption is here. Okay, multivariate. Okay, and then equal variance. Therefore got 2. Okay, altogether 6. Okay, so follow here got 6. So the key one we can use this one use the Mahalanobis. Yeah, and then box M. Yeah, okay. Multi-collinearity, group sample size. Okay, yeah. So here got 6 assumption. Okay. So okay, we see next. Yeah. Okay. Okay, from some can do, some not. Not our focus. Some we can do. Okay, we see the first one. Top 6 variable in the terms of their discriminant ability. Yeah, top 6. Yeah. So table 1, top 6. Therefore, top 6, of course, we find the one with the smallest p-value. Okay, therefore 1, 2, 3, 4, 5, 6. Okay, so smallest is better. Okay, in this context. Okay, therefore this is ANOVA. Okay, done already. Yeah. Okay. Okay. So we see next. Yeah. In this discriminant analysis, how many classification groups are there? Okay. So any hints from here? Okay, let's see. So this one we do know. Okay. Yeah, got. Yeah. Okay. So for this one we got 2. Okay, got 2. Okay, how I know? Because of this. Yeah, df. So k minus 1, therefore is 2. Therefore you got 2 groups. Okay, 2 groups. Okay. So you can see also I did not mention, but I can show you now, no problem. Can you see here? 3. You can see the F1 is 3, therefore got 4 groups. Okay, I mean the income categories got 4. Okay, yeah? So for this here, you got 2. Okay, yeah. Any question on this? Yeah. Okay. Okay. So if not, now we see. As you can see from the table 3, the 3 variables that finally enter the function 8. Okay, we see first. 8, 11, 5. Okay. 8, 11, 5. Okay. So they refer to this table. Okay, and then by examining the correlation matrix suggests one reason why x7 does not enter. Yeah. X7. Why x7 not enter? Okay. This is x7. So this is normal. This is normal correlation. Yeah. Normal correlation matrix. Okay. This one actually I also did not mention too much. But this one I think ignore. Of course I didn't show you this. Okay, it's okay. This one ignore. Yeah. So therefore not going to ask you this part. Okay. Yeah. Okay. So we see this one. Okay, this one I also did not mention in the class, but can discuss a bit. This one, yeah, I forgot to mention actually. This one, therefore, if now I mention, it means maybe still can answer in the test or quiz lah. Okay, so this idea is quite similar with the R square. Okay, so we can discuss at least, well, all 3 can discuss. Okay, all 3. No, this one cannot because here confirm must be 100%. But here you can use. Okay. So this is quite similar with R square, but it's in this context. Therefore, you can say like this. Okay. So these 3 variables. Okay, these 3 enter variables. Means here they use the stepwise. Okay, stepwise. So the 3 variables in the final model, they can explain. They can discriminate. Okay. It's okay, no problem. I can type. Okay. The 3 okay. The 3 independent variables in the final model has a discriminatory power. Where anyone? Discriminate, yeah.
discriminatory power.
Thank you. Okay, of 76.1%. Therefore, this is quite similar if asked. Okay, because already discussed, therefore, we still may ask in the test or exam. Okay, so of course, if you want to make it clear, you may mention also here 8, 11, 5. Okay. Yeah, like this. Already very good. Okay, yeah. So here actually got one interpretation, you get another one is the eigenvalue. Yeah. Okay. Eigenvalue would be more general. Okay, will be more general. This model, you can just say hi, hi. Yeah. This power, this model has yeah. Okay. Okay, okay. Okay. Yeah. Okay. That's all you can say. Yeah. Okay. Okay. So eigenvalue more than one is really good lah. Yeah, that's all we can say. Yeah, based on the eigenvalue, therefore either one is okay. Yeah. So we done already for for chapter 4. 4 or 3? 4. Okay. Okay. So 7 we done already 4. Okay. So any question? If no, we come back for no, either one. Okay, Loki saying either one. Meaning you mentioned either one. You mentioned this also good. This also good. Yeah, either one. If they say 2, you mention both lah. Okay. So because here only one function, therefore must be 100%. Therefore don't use this. Okay. So this one can, this one can. If 2 points, let's say they want 2 reasons. You mention 2 lah. You mention 2. I mean, let's say they want 2 interpretation. You mention 2. If one, either one is okay. Okay. Okay, so that's we done already for for the discriminant. Okay, any question is
So let's say if the table eigen values have 2 function, means we have to give explanation for the 2 function as well, is it? Or only
okay.
one?
Okay, let's say 2 function. Let's say 2 function. Okay, good. You try. Of course, it's a little bit subjective. If got 2 function, you may mention. Okay, depends on the value. Let's say for our example, okay, wait 1.3 something and also 0.04 something. Therefore, this one not too important. You mention one is enough. Okay, you mention only the first. Okay, but let's say 1.1, another one is this is 0.97. You mention both. Both important. Okay.
Okay, sir. Thank you.
Yeah.
Just wondering, sir, is it normal for more than one function, right? Because just now we mentioned that function 2 actually is talking about the residual, so it's pretty normal for any data set to have a residual. So I guess it's not very common to have in this case like one function only, right?
Okay, good question. So let's say they got only 2 groups, so confirm only one function. Can it be 2?
Oh, okay, makes
Yeah.
sense. Okay.
Okay, so if no question, so we done already for chapter 4. So we come back at 3:35 for logistic. Okay, yeah. Okay, so 3:35. Yeah, thank you.
Thank you, sir.
Okay, see you.